In this video, we discuss residuals and residual plots. So first we have to define what a residual is. Okay? And what a residual is just the distance that we talked about in the other video, the distance of yi minus y hat I. Okay? And we often just call it res. Okay, so this is the residual of the ith point. Okay, and remember, I is just an index. Okay, so a residual is the vertical distance between the point and the line. All right, so let's go through an example and discuss what residual means with respect to it. Okay, so here we have data, several individuals, I guess 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, n equals 12. There are 12 people. There are several people, n equals 12. There are 12 people listening to music for, I don't know, X number of hours. That is not a controlled variable. We also don't know how much or what type of music they listen to. All we know is that they listen to music right before they take an IQ exam. Okay, so for this person, let's call it person A, they listened to half an hour of music, and they got an IQ score of approximately 91. Okay, this person, however, listened to a ridiculous 8 hours of music before the exam, and they got approximate 130 score on the IQ exam. So this is the data we have. Let's say that this is our best fit line. Okay, this is the least squares line that minimizes the vertical distance between the point and some line. Okay. All right, so that's our regular scatter plot with the least squares line. Now we want to talk about a residual plot, because residuals represent this vertical distance. So how can we look at a graph of those distances? Well, the x value is going to be the same. Okay, remember that this point has the same x value as that point. So our explanatory axis, or our x-axis, is going to have the same variables. Every point is going to be graphed at the same x value. Okay, what changes is the y-axis. We're no longer looking at IQ score. What we're looking at are the differences between vertical distance. Okay, so we can say vertical distance. In general, residual plots, vertical axis isn't named. Okay, it's understood that this is the vertical distance. Okay, and if we look back at what a residual looks like, we can think of, well, if the point is above the line, then this value is greater than that value, and the residual will be positive. If the point is below the line, then this value is smaller than that value, and the residual will be negative. Why is that important? Well, when we look at the residual plot, we have a vertical axis at the 0, okay? And so the vertical distance will be negative when the point is below the line, and positive or above this line when the point is above the line. Okay. So for example, if we look at this first point graphed at half an hour, it has a positive distance of approximately 10. Okay, so we would plot this point. Okay, it's 0.5, comma 10. Alright, but what about this point here, the second point? It's graphed at approximately 2 hours, so 0, 1, 2, and it has a negative distance. Okay, so this point is a 90, and then this is about 82, so let's say it's about negative 8. Okay, and so this point will be closer to the line. Alright, so that's an example of how you would graph these points. Okay, so a corresponding residual plot looks like this, where the explanatory axis or x-axis or horizontal axis is the same as this one, and the vertical axis is different. It represents the vertical distance. Okay, this is our residual plot. But one thing to note, or I guess I want to call it a warning, and I'm going to put it in big red letters. Pay attention to scale. That when analyzing a residual plot, you want to look at the scale here, okay? Because remember that this was -8 and that this is +10. Even if they look like they're close to being 0, they are far from being 0, okay? So scale is important. Why is scale important? Well, the closer these points are to 0, the better fit this line is, okay? So what we want is a smaller scale on the y-axis to indicate the least squares line, LSQ, is a better or good fit. It's a good fit. Okay, that's very important. On the next page, we have an example of a residual plot for the data that might be better. Okay, so notice that the scale is much smaller here. Even though 4 is still large, we have a smaller scale. The other thing I wanted you to pay attention to is the pattern of the points as compared to this horizontal line. Okay, what is the pattern of the points? Well, there is no pattern. These points look random, so a randomized pattern also implies best fit. Okay, we don't want something like a circle here, or maybe a parabola or whatever. Some sort of pattern indicates that maybe this line, this linear form is not the correct form. Okay, maybe a exponential function would be a better form, and so you would need to fit the data to an exponential function, and that would require different modeling than we will learn in this statistical class. But that was something else I wanted to point out. When you see a residual plot, you want to look for a small scale randomized pattern. Okay, an even better fit would be if this was like 0.4 and 0.3 and 0.1 and 0.2, etc. It would make it a much better graph, but 4 is definitely smaller than 40. All right, the last thing we want to define when we're talking about scatter plots and regression, we want to define lurking variables. Because what we're trying to do is discuss how the response variable is influenced by some explanatory variable. For example, if we were talking about hips and waist, okay, if we wanted to say that hips indicate the size of the waist, what are some other things that influences the size of the waist? It can't just be the hip size, right? It could also be the type of food you eat, right? How much stress you have. Maybe you have a chemical imbalance, so you have a thyroid. Maybe you have a thyroid issue or something. You know, there are lots of things that influence the size of your waist. Okay, it's not just the size of the hips, and lurking variables really are a big deal when you're talking about observational data that is not controlled in any way. Okay, so for the rest of this, you should take some time and think about what are some examples of lurking variables, or variables that are not accounted for when plotting the data or collecting the data. And, do this for the music IQ experiment that we talked about earlier, okay? In summary for this video, we defined residuals. We went through an example where we were able to discuss what a residual plot is and how to interpret a residual plot.
My name is Llama, and I'm here to teach you stats, skilling you up with them cold hard facts. We live in a world of technology. They're collecting information on your humanity. Social networks, gaming, and in-home software.
Hello, Alexa.
Statistics helps us be more aware. Haters gonna hate my spicy lyrics. Why you gotta be so mean? Pulling me towards your extreme moods, but the median never fails to center me. 50 to my left, 50 to my right. Got these correlation and regression tools, forget them fools. My name is Llama, and I'm here to teach you stats, skilling you up with them cold hard facts. My name is Llama, and I'm here to teach you stats, skilling you up with them cold hard facts. The mean of the means is the mean. The mean of the means is the mean. The mean of the means is the mean is the mean of the means is the mean is the mean. Be careful not to fall in love. Statistical seduction from above. Your shape so beautifully symmetric to the eye with a single peak so high. I hypothesize and can testify that your p-value is the smallest I've seen. Mix that with a large power and I reach ecstasy. Your residuals defy the rest. A small scale randomized pattern tells me you are the best fit. My name is Llama, and I'm here to teach you stats, skilling you up with the cold hard facts. My confidence is so high, 95%. My margin of error so narrow, 1/10. Can you feel me? Can you feel me? I estimate your population parameter based on only one sampling. Oh, haven't the frequentists told you about me? We live in a world of data, attempting to understand life by statistical strife. The implicit bias of cops, success rate of them jocks, medical advances, and AI romances. Statistics.